Welcome back to Rice.AI Code Room. Today we are tackling LeetCode 3741, minimum distance between three equal elements 2. Let's explain the problem. We are given an array of integers. A tuple of three distinct indices is considered good if the array values at those indices are equal. The distance of a good tuple is the sum of the absolute differences between its indices. We need to find the minimum possible distance among all good tuples. In our example, the number 2 appears at indices 2, 4, and 6, and their calculated distance is 8. Let's clarify the math behind the distance formula. If we sort the indices such that I is less than j, which is less than k, we can drop the absolute value signs. The formula simplifies beautifully. The negative j and positive j cancel out, leaving us with exactly 2 times the quantity k minus I. This means the distance strictly depends on the gap between the first and last occurrence in our triplet. For our thought process, since our goal is to minimize 2 times the gap between the first and third index, we only need to look at adjacent triplets of the same number. If a number appears 4 times, forming a triplet with the first, second, and fourth occurrence will strictly have a larger distance than using the first 3. Therefore, we only track the last 2 seen positions for each number. Let's visualize the array from our example. If we trace the occurrences of the number 2, we find it at indices 2, 4, and 6. This forms our adjacent triplet. The first index is 2, and the third index is 6. The distance is 2 times 6 minus 2, which gives us 8. This is the minimum possible distance in this array. For the implementation, we can declare 2 integer arrays, first seen and second seen, both of size n plus 1, initialized to -1. These arrays will dynamically track the 2 most recent indices we have encountered for any given number in the array. We also initialize our minimum distance to infinity. Inside our main loop, we iterate through the array. For each value, we check if its first seen index is not -1. If it is valid, it means we have just found the third occurrence of this number, completing a triplet. We calculate the current distance as 2 times the current index minus the first seen index, and update our minimum distance. Finally, we must update our tracking pointers for the current value. We shift the second seen index into the first seen slot, and update the second seen index to be the current index I. After the loop finishes, we return the minimum distance, or -1 if no valid triplet was ever found. To wrap up, let's analyze the complexity. The time complexity is O of n, because we process the entire array exactly once in a single pass. The space complexity is also O of n, as we allocate 2 state tracking arrays of size n. This provides a highly optimal solution. Thank you for watching.